morning, everyone. Welcome to DSS Asia 2025. My name is Balachandar. I'm part of the field engineering from Yugabyte Bangalore, India. Yeah, my topic is going to be in YugabyteDB, how YugabyteDB empowers AI-powered fraud intelligence. So I'm just taking a detailed a demo also on this session. So let me quickly share my screen, and you can all have a look on that. YugabyteDB, as you all know, it's a distributed PostgreSQL, and which solves the scaling and resiliency seamlessly, and it is in a highly transactional database with a strong consistency. So though it's a multi-model database where you can get both the APIs of Postgres as well as Cassandra. So with that, where you can able to solve a lot of your use cases from a single database itself, right? So that's which clearly helps how YugabyteDB can help on your solving your scaling and resiliency problems. On top of that, it is highly Postgres compatible, right? The use case which I'm taking very specific to the fraud risk in financial transaction, particularly in UPI in India. As all of you know, what is UPI? UPI is a unified payment interface. It's an instant payment uh, from your mobile to any bank. It will happen in fraction of milliseconds to seconds, depends upon your network. So this has been started in 2016, close to 10 years. This is there in this market, and where plenty of real-time payments are happening quickly from person to person or person to merchant, right? So this can be person to person, means I can send it to my friend or family. Similarly, person to merchant means I can just scan a QR from a shop or any particular place where they will accept this UPI payment, right? Where there will be multiple banks being involved, from the acquirer to the sender or the issuer to the other side, right? So there are regulations are also on top of that, which is typically governed in India through NPCI, which is National Payment Corporation of India. So who is taking care of this very closely and seeing all these things from a authority perspective and regulatory perspective. What are the potential fraud risk in this UPI world, right? Because UPI is also one of the fast moving payment channel where people are immediately paying it and then getting it done. But there are plenty of fraud elements are also involved here. So it can be like a maybe a fake call saying that you did the payment a couple of minutes back, but your payment is not authorized and you have to share the OTP again. People may simply share their OTP, which is a one-time password or a PIN, without knowing the risk of sharing it, right? There are QR code scam, so where the users are asked to scan the QR to receive the money also, because it is not only sending the money, it is also receiving the money. There are QR tampering is also quite commonly been there in some of the incidents, very specifically where you think this is a legitimate QR, but actually the person who put his own QR where the money gone to his account rather than to that particular business account, right? So this is also happening in some of the shops and malls where to divert the payments. This is QR tampering. Fake UPI apps, there are plenty of cloned and look like UPI apps just to steal the credentials. So you may think you downloaded safely from the Play Store or App Store, but they are going to just steal your UPI ID or credentials. Similarly, there are like fraudsters send the request to send instead of a payment, right? So these are all one way of saying that, okay, you have to give the payment, and you may think it's a request, but it is ultimately taking your payment link and all those things. There is a SIM swap, which is where people are even nowadays facing this issue, which is a cloned SIM used to bypass your OTP to hijack your UPI access, because this is quite common in eSIM kind of electronic SIM came into the picture, where people are even facing these challenges. And there are account takeover, like where access via stolen OTP or app reinstallation. So you may be giving it someone to do the app installation, and they know your passcode and this thing. So right. So these are all the other way that we just need to take care of the account takeover. There are device binding abuse. There are merchant frauds. There are fake shops without no delivery of post payment. You are not getting any acknowledgement that your payment has been settled or not, right? So you may be thinking it is successfully gone, but later you may come to know that you have to send again or you have to owe again to them, because it is not been sent to the legitimate party or the person who involved on the opposite side. It has been some shops who took it from to their side, right? There are phishing links. There are plenty and plenty of phishings are there with these attacks. So they may be claiming that your payment is not settled, or you may be they may be saying that your payment is on hold. So you may be thinking that, okay, I need to clear, otherwise I may be getting into some sort of a penalty if I pass this deadline. So you will be immediately seeing these sort of phishing links to immediately send it, but that will ultimately gone to again to the wrong hand, right? There are some refund schemes. People will also take, okay, you did this, you may be getting a cash back. Now you need to do it again, maybe on top of some amount, then you will get a cashback. So sometimes this is also another way of cashback or offer scams are very high, which is a false cashback, which is all like they may be thinking, okay, I'm going to get the money back by doing like 10,000 to 15,000 worth of transaction. I may be getting a 2,000 worth of cashback. This is all the false cashback lures for UPI transfers. So we need to be very careful on all those things. So plenty of scenarios I listed here, only the 12. There are many more are there, right? So the thing is, why this sort of use cases are really important, and what is the problem statement we are going to solve here? See, there are plethora of transactions are happening in the UPI world today in India. So on an average in a month, it's close to 18 billion transactions are happening. 18 billion is a massive volume, and per day it is close to 900, or even like a huge number of millions, right? So it's a transactions are happening, right? So this tells like where exactly the world is moving, like where the volume is really high, but however the flagging the suspicious transaction is one of the thing which is already happening by taking care of lot of classifications model, by taking care of lot of transactional patterns, by understanding the person's persona, like what is he and why he is doing at this odd timing. Of course there are plethora of monitorings are in place, but still the AI is also being used across some of the banks, even our regulators, and even everywhere there are some AI models are flagging these suspicious transactions to some extent at the database level or at the application level to help them it, right? Now, coming to this particular use case of YugabyteDB, we took a use case to see how human in the loop in fraud detection is even helping, where financial fraud patterns are constantly evolving, and where AI model can sometime give some sort of uh, maybe it's a false positive, or it can miss the contextual, or even it will miss the novel fraud cases also, right? So that's where a human intervention is to some extent to see like how we can do a feedback system to making sure that there are some edge cases being flagged as suspicious but they are not actual suspicious, or being flagged as legitimate but they are not legitimate, right? So this sort of a constant HIT we call, right, like the human in the loop, will help us to improve our model decisions, to understand what sort of model can be even tuned and even trained, and ensure that the classification works well, and the flagging is even accurately flagging it on the transactional database, right? YugabyteDB is a transactional database, as I said earlier. So it is also helping you to store vector data, and where it supports a lot of embeddings for these sort of use cases. And then one good thing is you are having a UPI data on the database. On the other side, you can also keep a vector column to just embed those data from your prompt by taking into any AI model, be it on-prem or be it cloud-based model, right? Example like even OpenAI or Anthropic, right? Whatever it is, right? So you can even take a Llama model at your own on-prem, and you can even train those things, right? So there are plenty of ways to get those embeddings and park those embeddings in YugabyteDB. The thing is now how YugabyteDB can help on these part of things, right? So PGVector is one of the extension which is comes out of the box in YugabyteDB, because YugabyteDB is a highly Postgres compatible database, which we all know, and it is horizontally scalable across your regions within India, or across your availability zones within your data centers, or even across the cloud, right? So it's again strong, consistent database. It ensure that it will be highly resilient to take care of your node failure, because it's a built-in replication available, which is synchronously replicating with the help of Raft and all those things. So I'm not getting into that very much detail of the internals part, but still I want to say that this is consistent performance both for your transactional and vector workloads. That's where YugabyteDB really stands out for taking care of your hybrid use cases, which needs both to query from transactional reason as well as from the vector. Both can integrated seamlessly, and where it can work in the same database, and where you can even continue use your cloud native applications or GenAI applications which you are going to use it, right? So the good thing about this database is like it's horizontally scalable, so you don't need to worry about any ceiling limit of your vertical configuration what you currently have it. Like I may have only 32 core. What I will do, I don't have a limit after that, so it is not a problem. It's a forklift architecture. You can keep adding more nodes horizontally, and you can also remove the node without any downtime. So that's where YugabyteDB is really helping you to solve all your um, downtime related issues. It will not expect any downtime. It's a zero downtime database, and its RPO is zero, because it's the copy of the data can be replicated across your nodes, across your regions, across your clouds also, where always the copy will be there. Again, the copy can be configured with the help of your replication factor of 3 or 5, right? So that's where we have the trade-off very clearly with the help of RPO is zero. And RTO is where the raft-based thing will take within a fraction of milliseconds to seconds, which depends upon your where your leaders are being there, right? So this is again being configured to make sure your RTO is also going to be quicker in that perspective. All right. Let me talk about pre-Gen AI, and now we are in the generative AI world. So pre-Gen AI, before birth of a cloud native app, right? So there are a lot of monolithic applications are there in the world with a lot of store procedures, lot of siloed module, which is all going to work independently without sharing the data each other. Where we need to bring data through batch jobs or sort of file-based exports, and then that application can work after the file is landed or file is being available to that particular application. When cloud native pattern came into this world like 15, 20 years back, where many of them started building the cloud native patterns, making sure that how I can able to bring more atomic level of control at the application with the help of microservices. So where the microservices are really helping us to come out of the legacy way of maintaining our application. There are sheer volume of data which we need to even take care of this legacy world. So all of them is being now being easily with the help of these modernized microservices architecture, which takes care of your workload seamlessly to very specific endpoints, where it can able to work like a outbox model also, right? There are plenty of models are there. Now, this innovation is being always there. The birth of Gen AI is not a death of cloud native app. So birth of Gen AI, it's complementing the cloud native app, and in making sure that even the cloud native apps are even going to take the advantage of Gen AI applications, and it can even build a stronger and stronger with the help of MCP and other things, right? Which is a model context protocol, which is also going to complement along with your current workload, what you are already solving some of the use cases. Now let's look at the post Gen AI. Now Gen AI is already there in the world, where there are agentic AI is all there in the world. Now there are like what are the changes are there? Now people are going to call their cloud native app is like a Gen AI app, because it is already added the flavor of AI. And now where it comes to the application life cycle from the Gen AI world. So we have to first prepare the knowledge and store the data, and what data we have to model it, and how to create the indexes, how to embed the data, how to store it in the form of vector. Then we need to bring sort of MCP servers and advertise the capabilities, configuring the MCP clients. This is the where we have to create any all the next set of applications which enable the agent to agent communications, right? Which is an agentic AI, where a lot of agentic AI workflows are there, agentic AI models are there, which we even need to some sort of an orchestration. So, and all those things which we can communicate and collaborate with multiple agents. That's a cycle which is already evolving in the industry, where many of the customers are started adopting. Coming very specific to Yugabyte perspective, we are at the 1 and 2 portion of the life cycle, which is the basic, because your data is already there in the DB. You don't need to build another effort to move this data to any sort of vector DB or vector store. With the help of PGVector, you can easily able to just embed the data, store the vector indexes, whatever we support, right? Like it can be different way of storing it. Like if we can look at it, so we are even storing the vector. Either it can be a HNSW with a Euclidean index or a cosine index. So based on the cosine distance or a Euclidean formula, where you are able to do the k nearest neighbor kind of model, where you can quickly get it by identifying the closest match from your semantic search whenever you are going to get it actually, right? So these examples will tells us like this is my input vector using the HNSW index type. So where I may be again doing my distance functions either with a cosine model or with the Euclidean model. I am loading the data either from my file, because I'm not going to use any tool here. Within the same thing I can use, or even I can use an insert statement to another table also. Either way is possible. Then I'm going to take my vector embedding by keeping the limiting distance, like find out within the closest one across these 10 indexes, right? So this is where the dimensionality, like a 384 is the dimensionality if we are going to use. So then there will be a 384 float digits are going to be embedded across for your each and every row that is going to be populated, right? This is all good. So from the modeling perspective and embedding perspective, like how we can at least store the hybrid data. By one hand, the same table is containing your actual transaction, on the other column which is containing your embedding data. Well, coming to this use case on the fraud transaction, YugabyteDB is going to continue store this data, assuming that you are bringing your UPI workload in YugabyteDB. You can continue use that model, whatever you already modeled. Only the portion that you may need to build an additional table or extending the table to add the vector column to store all your embeddings, right? So in this use case, I'm going to talk about how I'm going to solve this fraud intelligence in the human in the loop mechanism. Like the very simple architecture I took it is with the help of fast API as a backend, which is going to do my vector search and also calling my feedback from the same table to lock my feedback data. I used here Anthropic Cloud AI model for both prompting and filtering, and also sending the message for a cloud-based um, um, uh, validation perspective. The cloud is actually also going to help me to classify whether this is fraud or not. Those are all the things are also I'm just going to do that. And at the end, I'm just using for Steamlit to just to show the UI, like how this transaction comes out of the database and how it is interacting with my Anthropic model and other things, right? All right, so the nearest neighbor search, I'm going to show a demo and see how they are close to each other in a given query, and without scanning every time extensively, which is going to be much faster than exact nearest neighbor for large data sets. So there are, it will results based on my distance value. I can say 2 or 3 or 5, whatever I can give the limit value, can show that. So with that, we will quickly jump into a demo. So let me just take a demo there straight away. Thank you. Hope my screen is visible. Okay. So this is my database. As you can see here, I just created a cluster in YugabyteDB with the latest preview version. So let me just yeah. So this is a PostgreSQL 15.2, which is currently deployed with Yugabyte 2.25.1 version. So which is our preview release. So which has the high Postgres compatibility, and also with vector extension is also being packed and it is available, right? Yeah, please try to download and leverage this version so you will be able to easily understand how the vector embedding can be helpful. All right. So the database I just took here is the UPI database. So I modeled the two tables. So there are already two tables I just created. The first table is more of UPI transactions. As you can see here, so this table has my transaction ID, the payer VPA, which is called the virtual payment address, the payee, the person whom I am going to pay, the amount, the transaction time from which device, if it is a from mobile device or maybe any QR device. What is IP address, merchant category? It can be again travel, shopping, utilities, whatever it is, right? It can be business. The location where I'm doing it, and then the transaction type, whether it is like a P2P or P2M, is it fraud? So this classification based on some rule engine which is already classifying it as a fraud. But however, this is where the human in the loop is going to revalidate this fraud and seeing that. And finally, you can see the embedding of this particular row also, right? So this is what the embeddings are also being available with our vector format. So now this is actually a really cool feature where you don't need to again move to another one. So it is released in the same database. So let me just select few records, whatever I loaded. So let me just take a UPA transaction, which is, I will just see that. Yeah, as you can see here, yeah, this is a data. So this is again all synthetic or handcrafted data, nothing being personal. So you can see that this is a data, which is the amount, what is the transaction type, P2P or P2 person to merchant, right? So all those things, whether this is fraud or not, all those things, and from which IP address it is being came. So all those things are clearly telling you, and this is my complete the vector embedded data, what I already embedded in the run with the embedded model using Anthropic. Right? So now this is all cool. Now let's go and see in the UI how this is going to do. And before that, I will also show the feedback table. That's where the human in the loop is important. So if you just see the feedback table also, the structure of the feedback table. So there is the fraud feedback. I'm just doing it. So this is also a simple table to take the transaction ID and the reviewer, and he's taking a decision and writing a comments and review that. So let me take some record here. Let me just take, so this is already having some row. So what I will do, I will truncate this table. Let's go from scratch. Yeah. All right. Yeah, the data is truncated now. So let's look at whether any data is there. Yeah, it's 0 rows. As you can see here, earlier there are some rows are there. So now I just cleaned up everything. So let me go to the UI now. So this is my UI. So as you can see here earlier, there are some feedbacks. Now I'm just going to review it. There is no feedback. So there are, this is the simple UI. So which basically telling like what sort of semantic query you want to put it, like to search any suspicious transaction. So this is where the top K results you want to limit it, like within the vector distance, you want to just to see only 3, or this one can put at search. And there is also a dashboard which keeps telling like how many donation based transactions being classified as fraud, how many of them are food, shopping, travel, utilities, and you can see the heat map also. And between 12 a.m. to 1 a.m., these many donations happen. 1 o'clock, these donations happen. So these are all the different time zone that you can see in a day. This is the heat map on an average, which is telling like on an average how many transactions are going across. So the donation is one of the high red, where generally that's where people used to send the money to many business or person, just classifying it as a donation. That can be a legitimate donation category, or that can be even lead to some fraud type of a transaction also. Yeah, but there are some high foot transaction. There are some unusual transactions happens at the odd hours, like early morning, 1 o'clock, 2 o'clock, 3 o'clock, which may not be usual for those sort of transactions. Something like someone did the shopping in a mall at saying 3 o'clock, when definitely the mall itself is closed, then it will be clearly saying there is something wrong, right? So based on that, we classified some of them that can be legitimate. If it can be an online shopping, then you cannot say that is also a fraud, right? So if it is a mall, acceptable, but if it is online, you cannot accept it, because the person may be travel, he may be in different time zone, he may be outside of India, he can still try to do through online. So there are way that we can do it with the help of anything, right? So the way we need to classify and understand with the help of the feedback summary is one of the important thing to take the fraud decision. And before that, let's go and query some of the things. So just to simplify these prompts, I just already kept some prompts, but of course I will customize and ask the questions. So I'm just going to ask something like a high value transaction amount. The interest of time, I'm just pasting it here. I'm just asking high value UPI transaction amount about 10,000 with the type as donation in Chennai location. Let's look at whether the search is giving the results or not, right? So this is actually behind the scene, it is pulling the request. So in the meantime, I will just simply tell you this is the application which I am currently running. As soon as I hit the prompt, as you can see here, this is the prompt which I just sent it. And this is being embedded prompt, which comes from the Anthropic, where the API used to get those things. So this is also able to parse my data based on my semantic query, like what is the location, what is the transaction type, category. Of course, you can customize those prompts to even apply some of the transaction filter. And it is now the query got formed. As you can clearly see that, okay, this is a query. So this is the location and all those things. Now the search is actually return the data based on what I just queried it. Let's go and see that, right? So there are three transactions with the limit I asked. About 10,000 I asked. Above that is also satisfied, which is 13,000, 15,000, and 10,000. Let's go and see whether these are all Chennai transactions. Yes, they are Chennai transactions, which gone to high value as a donation. This is person to merchant, that is P2M, right? And this is a device ID. Again, this is anonymized. I just put it. And this IP address is also the synthetic data. Is it a fraud? Yes, it's a fraud. That's how it is classified. Let's understand whether this is really fraud, and let's try to explain with the Claude Anthropic. I'm just running it and asking now because I don't know this is fraud or not, right? Let's take the with the help of AI and see how this is going to help me here, right? Um, Okay. The Claude's explanation is telling the transaction is likely fraudulent because based on several flags, the combination of high amount, which is 13,000 being transferred to a donation merchant at 22:16 in the late night hours is suspicious, right? As a legitimate charitable donations of this magnitude generally occur in the regular business hours. Additionally, donation merchant category is a commonly exploited fraudsters to create seemingly legitimate looking transaction that victims might not immediately question or investigate thoroughly, right? This is one of the category generally where money being floated through UPI today, where people are not able to trace whether they are legitimate or not. Of course, this is still we suspect as a fraud. We can just leave it to a fraud. But if you want to challenge it and just check, no, this is not a fraud because I know this person, I know this merchant, right? This is where we have to take a call from the monitoring perspective. Okay, here I'm putting my name. I'm just saying that this is not a fraud. Knowing the customer's profile, I am classifying as a non-fraud transaction. This is my comment. Let's see, this is where human in the loop is helping us to do it. Now, I just submitted. Let's look at the feedback. Now, this is the feedback I got. This is the reviewer I did. This is the one it is saying. Now I am saying not a fraud. That's why you can see the color. So this really helped me to search the transaction with my semantic query because I don't want to write a query to put a lot of things because person on the other side not to be technical. So that's where RAG kind of use cases, which is the retrieval augmented generation use cases with the semantic search are really going to help us on solving these type of problems quickly. And on top of that, where it is also helping us to validate with again cloud or OpenAI to send these things and making sure how this is all being correctly explained based on this transaction. You can see that, right? So now feedback is submitted. Let's try another prompt, right? I am okay with the Chennai. I want to see in Bangalore, right? High value transaction. I'm just simply changing the location. Let's see how the database is returning the results, right? So this UI, what you are seeing, which is completely built in Streamlit. So the Streamlit is used as also I constructed here. If you look at it, I think this is also currently I just put it where it is using again the SQL Alchemy to connect it. And there are dashboard related queries, or you can see that, right? This is where I just running my Streamlit. So if you look at the streamlet, like it is already having what are the fraud classified, and there is also the one thing what I didn't tell you is the repeat offender devices or IP addresses, right? This is very important for which devices are being frequently used for involving on this transaction. What is their corresponding IP address? How many such transactions are also coming, right? So this way it ensures that like 61 transactions are being tagged on this and doing that actually, right? Right. Now, let's go and just see that whether the transaction what I queried are Bangalore, which is again 10,000 high. Yeah, it is all about 10,000. Let's look at whether these are Bangalore. Yes, these are Bangalore. Donation again, then again it is coming there, right? So, okay, I just put high value UPA transaction, but let me go with the semantic search of checking whether any other category of that one, right? Let me take a next prompt. So, I'm just going to take maybe so like okay, identify ID value transaction. I put it. I also want to take any large UPI transfer made at the odd hours, right? That may be a next question I can also ask, or I can even write a very detailed English. Let me take the next one, right? So in this case, the next one I'm going to take here is. This is another semantic query. I'm just saying review this transaction between a customer and a merchant based on the transaction type, location, if you suspect. Justify reasoning for 2-3 sentences, right? So I'm just going to remove this because it is not, I want to take justification after that. Let me just take here. I want to filter only the frauders transaction where I want to see like which are the transactions are already being classified as a fraud, where the human in the loop is really important for this set of transaction, right? So my query is already been submitted. So as you can see here, it is already there with my database. So if we can just go and see that, yeah, this is my prompt. So merchant suspicious, I'm just saying again, I'm using this is the API I'm using for Anthropic, right? So which is where I'm getting that. I think the query is being now hit into the database after the embeddings are being available. So now let's go and see that there are 3 transactions I put it. Let's look at that. So one is saying Bangalore, which is food. Another one is saying Delhi, which is travel. And the third one, which is going to be again, what is the category is a donation. Okay. Let's take the travel and food to classify that, right? Let's look at the travel part, first one. It is saying location as Delhi, though it is fraud is not been true. But I want to check whether this is a legitimate transaction. The amount looks 25,000, sorry, 2,544. Let's explain with the cloud and Anthropic and see what is their response, right? I'm just checking how this is being available in that case, right? Okay. So it is saying based on the transaction data provided, the UPI transaction appears to have a low fraud risk because the amount is low. The transaction shows a normal characteristics with a reasonable amount of a travel merchant, consistent person to merchant transaction type, and all the fields appear to be properly formatted in a legitimate VPA, which is a virtual wallet address, right? What we used to store it in the UPI ID, right? So from recognized banks between ICICI and HDFC, that is what they are just classifying here, right? So which is very good that at least it is being tagged here. The transaction again falls in the 8 p.m., which is typical business hours. Amount is moderate and travel services, and no obvious red flags or unusual format. So it very validated person to merchants banks also, as all those things it classified. But you still suspect no, this is a fraud or something, you want to tag it, then you can go and tag it. Otherwise you can leave it, right? So let's go to the next transaction. So this is a food actually. So this is actually again coming up with the fraud tag itself is true. So let's go and just analyze here. Let's see what is the Claude's analysis here. So it is also hitting an API. So it is immediately comes up. Yeah. So as soon as it says that this transaction is likely fraudulent for several red flags, the amount 11,642 is usually high for a food merchant transaction, which typically involves in a smaller amounts or meal or groceries, because this is person, right? We don't know, this person can gone in with the group or maybe a team gathering or maybe anything is possible, right? We cannot generalize one person can mean eat only one meal or one a dinner, right? Or it's one buffet. That is not something we accept sometime, because we go on for a group or a company dinner, even he can able to pay this much amount. But the combination of high value payment to a food merchant along with the specific device and IP address pattern has to be assessed. That is most important here. So you want to leave it to a fraud? No, I know this person, I know this merchant, this is already been analyzed, then I can go straight away. I'm just making it as a non-fraud in that case. So I'm just making it's not a fraud, right? It's not a fraud. I'm just saying person name is, yeah, I can put BS analyst as my name, right? Let's see, this feedback is submitted. Yeah, feedback is submitted. As soon as you see there is already one feedback I already did. Now there is another person, BS analyst, is also now coming here. This way, the human in the loop is even keep on helping you to tag it and do that one, right? So with that, I will wrap up the quick demo, and let's see like the database side, what are all the other things that we did it, right? Let me just go and just see that. So the table already cleaned up for fraud feedback before demo. So now if you look at it, there are two transactions. I did it. So one is for not fraud, I'm classifying. There is a another one is also not fraud, but the different reviewer are there, and this has all been there, right? Yeah. So this concludes. Though AI is good, the AI is really helping us to classify whether it is a fraudulent transaction or a non-fraudulent transaction. Still, human in the loop, which is essential to even analyze the transactional data from YugabyteDB itself to validate whether this is legitimate fraud is classified is correct or not. This way, we can even retrain the model, like I said earlier, and we can even tune it. It depends upon like what sort of precision we may need to even validate from that parameters, right? So yeah, this at least helps us to understand how UPI kind of use case can easily fit into YugabyteDB, where you can keep a large volume of data easily, as YugabyteDB is a highly resilient and a strong, consistent database, which is purpose built for transactional workload. On top of that, it supports the vector embedding, and seamless semantic query search or RAG use cases can be built in top of that easily, and where you can bring any model to your on-prem or your cloud-based model at any time by taking this sort of advantages. So yeah, with that, I'm signing off. Thank you once again, and please continue watch the rest of the sessions. Have a nice day. Thank you so much.